which is this Newton time meter from now on will be called Joule. And Joule is equivalent also, since Newton is kilogram time meter per second square, and we multiply by meter, this is the same. So all these three units are equivalent. So by definition, what will be the Joule? By definition, Joule is the amount of energy. Joule, 1 Joule is the amount of energy that I will spend when I move with 1 Newton force this object for 1 meter. So if I am able to move with 1 Newton force for 1 meter this object, I will spend 1 Joule of energy. This is the definition of Joule, which is there. The amount of energy needed to move one object for 1 meter with a force of 1 Newton. So if you do that, you will spend 1 Joule. Okay. By definition, that is the definition of work. How to apply this definition? Very simple. Let's do an example. We have example 1 for work. I mean for 2, because I already did 1. Let's say that we have an object, like a box, which you are pulling with a force. Let's say, for instance, 40 Newton. The angle, 37 degrees. The mass, 10 kilograms. The friction, mu, 0.2. The question, find the work done by each force acting. B, find the net work. So, the question is the following. We have an object which we are rolling or pulling like this at a constant force. I apply the constant force, correct, along the displacement of 40 Newton. The coefficient of friction is the same and the mass is the same all the time, so the friction will be constant. The gravity will become constant and the normal force will be constant. So in order to find the work, I just need to find the work done by each force, but not necessarily applying this definition, which is the same than this. But because we know that if the force is constant, we can apply this formula for work. We will apply all the way this formula to find all work. But in order to find all work, you need to know the forces that are doing work. What forces are acting there?
Normal.
The pulling force. What else?
Normal.
Normal force.
Gravity.
Gravity
Friction.
and friction. These are all the forces acting here. So the point or the question part A is to find the work done by each particular force. Each particular force. So I need to find the work done by the force. I need to find the work done by the friction. I need to find the work done by Fn. I need to find the work done by Fg. So that's what I want to do now. I apply just the definition of work. So if I
displacement, right?
Oh, the displacement is not given, so I will give delta x, let's say that is 5 meter. 5 meter. That's the displacement. I have to give the displacement, yes, thank you. Okay, knowing that, we go to the definition and we say, oh, A, let me start finding the work done by the pulling force. By definition, what will be? Strictly, we apply the definition. The force time the magnitude of the displacement time what? Cosine of the angle between, which I won't say theta, I will put here alpha. Why I will put alpha? To let you know that alpha change from force to force. It's not theta. In this case, because I said that theta is a 37 degree, you can confuse with theta, and you, for all forces, you will use the same theta. No. is the angle between the force in question and the displacement. For this reason, I am using here alpha, which is the same than theta, but it's just to let you know that alpha is not the same for all forces. So we get F delta x cosine theta. In this case, for the force, pulling force is theta. So alpha becomes theta. What is a theta in this case? So we get here 40, delta x 5. So 40 times 5, how much? Cosine 37. So the work done by the pulling force, 160. 160 joule. So will be 200 cosine 37. Okay. So 160 joules. Then B. Let's say this is A. I will put A. But in A, I just ask to find all forces. So will be A1. A2 will be to find the work done by which force? What is another force involved there? The friction. Work done by the friction. By definition, what is the friction? What is the friction? Equal to mu times the normal force. Times what? That's mu Fn. Let me just put it this, the friction. Before that. The friction times what? The displacement times what? Cosine of the angle between whom and whom? Between what force and which displacement? Between delta x and the friction. In which direction is the friction?
180.
180. So it's this way. If you cannot see the angle, you have to use your hand. In which direction is the friction? In which direction is delta x? What is the angle between them? 180. So cosine 180. Can you see that it's not 37? Can you see now why I put alpha instead of theta? Just to let you know that the angle will change from force to force. So what is cosine of 180? Negative 1. So we get always for the friction negative F delta x. That's the formula for the work done by the friction. Always. Negative. Why negative? It's the work done by the friction taking energy or giving energy to the system. Taking energy to the system. It's going away from the system. So for this reason it's negative. So what will be the friction equal to? If I give the friction, if I said the friction is 10 Newton, you just plug it in here, 10 Newton. But I didn't give the friction. What did I give? And I didn't give the normal force, but we can find it. What did I give? The mass and the mu. If I give mu, we replace the friction by what? Mu? No. Not always is mg. I said not always is mg. Mu times what is the friction? Normal force. And the normal force is not mg always. Times delta x. Negative. Okay, what is Fn? Can I find it? Look at the picture and tell me what will be Fn. I mean, apply the Newton laws along Y and tell me what is Fn. So what is Fn? Mg? F sine theta. Mg minus F sine theta. Mg, so Fn plus F sine theta minus Mg equals 0. This is the Newton's first law along Y.